Hello and welcome back to Wider 360. Today we are going to look at how to find the slope of this polar curve, which is of the equation r is equal to 1 minus cos theta. One thing that we have to take note of is that this polar equation or polar curve can also be written in the form, let me get a pen. I'm going to use a blue pen. It can be written in the form r is equal to f of theta. F of theta. So we will go ahead and find the slope, which is given by f prime of theta, or you can say dy dx. Yeah, but we are using f prime of theta, and we know the general formula for finding the slope is given by f prime of theta, which is equal to dr d theta multiplied by sine theta plus r cos theta. All this divided by dr d theta multiplied by the cosine of theta minus r sine theta. Now that we know the formula, we can go ahead and find the slope. But before we do that, I want us to find the r d theta. We know that r is equal to 1 minus cos theta. So if we are to differentiate this with respect to theta, we will get sine theta. Yeah, if we differentiate 1, we get 0, and if we differentiate minus cos theta, we get sine theta. So we will go ahead and plug in the value of the r sine theta into the formula for finding the slope. So we will say f prime of theta, which is our dy dx, which is also known as the gradient function or the slope, is equal to, we know it was equal to the r d theta multiplied by sine theta. Okay, and then plus r cos theta, all divided by the r d theta multiplied by cos theta minus r sine theta. And we know, we just saw that the r d theta is equal to sine theta. So we will go ahead, plug in the values, and get our slope or the gradient function, which is the same as f prime of theta to be equal to sine theta. We are plugging in the values, substituting the value of the r d theta here, which is sine theta multiplied by sine theta. Let me put a dot here to indicate multiplication, plus cos r cos theta, multiplied by r cos theta, and the whole of this divided by sine theta multiplied by cos theta minus r sine theta. And we know from the beginning the value of r was given in the question as 1 minus cos theta. You can find it here. I just highlighted that. So we will go back to the gradient function and plug in the values of r. But before we do that, we can also do the multiplication as we go. So we will say that the slope will be equal to sine theta multiplied by sine theta will give us sine squared theta plus r. We know r was equal to 1 minus cos theta, which is multiplied by cos theta. All this divided by, and here we have sine theta multiplied by cos theta, which is sine theta cos theta, minus r, which is 1 minus cos theta multiplied by sine theta. So we will go ahead and expand the brackets. Hold on just a minute. Expanding will give us sine squared theta plus cos theta minus, that's cos theta times 1, and cos theta times cos theta, that will be cos squared theta. All this divided by sine theta cos theta minus sine theta this should be in brackets minus sine theta, and then it goes plus, or let me just do another minus since I have this bracket here, minus sine theta cos theta, and this can go all the way to that side. If we remember from the trig identities, you will know that one of the identities says that cos squared theta minus sine squared theta is equal to cos 2 theta. Cos 2 theta. Let me just delete everything and then rewrite that so that it will be bold enough, and I'll have more space. We have cos squared theta minus sine squared theta as equal to cos 2 theta. That's the identity. And here we have sine squared theta minus cos squared theta, which is just like multiplying through this identity by a -1, or maybe dividing through by a -1. So we can say sine squared theta minus cos squared theta will be equal to negative cos 2 theta. So we will go ahead and then substitute that here. We have sine squared theta minus cos squared theta. We know that one to be minus 2 cos theta. So we will write first cos theta, which is found here. We'll go ahead and say that. We write that one, and then we go ahead with minus cos 2 theta. All of this divided by, and at the denominator side here, let me expand that one also. We get sine theta cos theta minus sine theta plus sine theta cos theta. And then we will go ahead again and say we have this function to be equal to cos theta minus cos 2 theta, all this divided by, and you can see over here also that sine theta cos theta plus cos theta sine theta is the same as that one will be equal to sine 2 theta. So divided by sine 2 theta, which is for the sine theta cos theta plus sine theta cos theta. So minus sine theta. At this point, we can plug in the value of the theta, which was given in the question, because this equation here is the gradient function. So we know theta was given to be pi over 2. So we would say the slope, which is f prime of theta, will be equal to cos pi over 2 minus cos 2 pi over 2, all this divided by sine 2 pi over 2 multiplied by pi over 2 minus sine pi over 2. And this will be equal to cos pi out of 2 minus cos pi, since those two cross out, all this divided by sine pi minus sine pi over 2. And we know that cos pi over 2 is 0 and cos pi is -1. The same way sine pi is 0 and sine pi over 2 is 1. So plugging in those values, we get the slope to be equal to 0 minus -1. All this divided by 0. Sine is 0 minus 1. And this will be equal to -1, because 0 minus -1 will be +1 divided by -1. And the final answer here becomes -1. So this tells us that the slope of the polar curve that was given as r is equal to 1 minus cos theta is equal to -1. Thank you very much for watching this video. Please don't forget to like the video if you enjoyed it, and if you have any question or anything, you can leave it in the comment section. Don't also forget to subscribe to the channel. Thank you very much. Bye bye.